All right, so Felix throws a cat at an angle that we don't know, call that theta. We have a speed of 30 meters per second, and I've changed the problem and made the range, the distance that it goes horizontally, 80 meters. That makes it a little more realistic, and it'll let you practice again with your own numbers. I've got a friend out there 80 meters away where they're going to catch the cat carefully. The angle that we threw the cat, that Felix threw the cat, is unknown. It could be really shallow like this one. It could be steeper. We're really not sure. But we can write an equation for the vertical component of the velocity, which would be 30 sine theta. We can write an equation for the horizontal component, which would be 30 cosine theta. And you can see, since we don't know the angle, we could have different shapes here. It could be like this. It could be like this. It could be even steeper. I'm really not sure. But it's going to go 80 meters horizontally. So let's take a look at what happens when we throw into the math here. Going up vertically, we know that if we use half the time, we're going to get a VF of 0. Let me just show that real quick. If we have the beginning be the beginning, so our initial velocity is 30 sine theta, we have the end at the top, so that's going to be a VF of 0. I can say VF equals VI plus AT, 0 being VF, 30 sine theta, which is ugly, but that's the vertical initial velocity. So we put that in for VI. A is negative 10. T is the time on the way up only. So that's half the time. Later on, we're going to need to multiply that by 2. Anyway, we can go ahead and take this 30 sine theta over to the other side, makes it negative. Then the negatives are going to cancel. We can divide by 10. We get an expression for the time. Notice this is the time just on the way up. So if we multiply that time on the way up by 2, we're going to get the total time in the air. Horizontally is a lot easier. It goes 80 meters horizontally. The horizontal speed here is 30 cosine theta. We saw that earlier here because that's the horizontal, right, velocity initially. And that stays the same since horizontal is not going to be affected by acceleration due to gravity. It just stays 30 cosine theta the whole time, which means we can use a lot easier equation when we do that. And we get this t equals 80 over 30 cosine theta for the time. Now the time's the same. The time that it moves horizontally and the total time that we had in the air vertically are equal to each other. So what we're going to do here is, in a calculator, we can go ahead and let me shrink this down a little bit so we can see it nicely. We can go ahead and take our y equals and clear that out. Let's also make sure we're in degrees. So I'll go mode, and sure enough, I'm in degrees. So that's nice. Come back out here. And in y1, I can go ahead and put this in here. So we get 2 times 30. You can simplify this if you want, but you don't need to. Times sine of x. I'm going to have x be theta for convenience. So 230 sine x divided by 10. Okay, and on the next one, I'm going to have 80 divided by, and I got to be careful here, I'm going to use parentheses because 30 cosine theta, all that needs to be in the denominator. So I'll put a parenthesis to make sure that's the case. And so I've got 30 cosine x. And those are my 2. Now I'm going to go to my window and think about things. X is theta, and t is time. So for the time, I think, that's the y, so I think I'll come down here and have my time go from a y min of 0, because it's got to take some time, to say 4 seconds. Should be enough. We could go 5 if you want to be careful. I guess I'll go 5. Okay, if we come up here, x is our angles, and it's 0 to 90 is all the possible things that we could have. And let's take a look at our graph and see what we get. So these are not the paths of the object. These are just these arbitrary equations that we've made where it looks like I'm not in the range here, so I'm going to have to redo it, but it looks like t here being solved for is y, so the time for, looks like maybe another solution up here is more. So I'm going to go ahead and look at my window differently here and have this time be, why don't I go with 8 seconds? Should be enough. Let's take a look again. So 0 to 90, these are the possible angles that we're looking for. And again, these graphs are just the graphs of these curves. They're irrelevant in terms of the actual path that the object's taking. So here we have two solutions, and I can find them both by simply going second, calculate intersection 5, first curve, second curve, guess, and I'll just press enter. This time it'll pick one or the other. On the second time, so it found this one here, it looks like it's about 31.3. Let me go ahead and screenshot that so we'll remember that number. The other one, let's take a look and find the other one. For the other one, we'll go second, calculate again. We'll go with intersection. First curve, second curve, but for the guess, I got to go over to that thing. Okay, so I'm zipping over here. And now hopefully we'll find that one. And it looks like this solution is 58.6. So we found two intersections. One is 31.3. The other is 58.6. So those are our two angles that could work out. Let's just take a second, and I'm curious if we can make this work out. So 31.3. Initial speed of 30. If I go with 31, just say, I'll fire that. So here's the one it's a shallow one. Okay, and if I go ahead and put in the other angle that we found, which was in the calculator there, 58.6. I doubt this is going to work out because we used 10. We should have used 9.8, but hopefully it'll be close. So hopefully it comes in also in a similar range. Not too bad. So they land here at the same point. The range is saying 82, but I think it's using 9.8, and this is software. But pretty good. So you can see we have two solutions. One is shallower, the other is steeper, and that gives us our two solutions for the angle, one being 58.6, and the other one here we can see being 31.3 for this problem. When you do yours again, you'll obviously get different answers because number 7, I chose different numbers. Hope that helps. Good luck. Let me know if you need further help.